All right, in this video, we're going to continue to learn how to factor, but we're going to be using some special factoring patterns that might be able to save us some time. Both these patterns involve perfect squares, so again, I hope you're continuing to get better at mastering what a perfect square is and what numbers are perfect squares. First factoring pattern we'll use is called the difference of two squares pattern. It starts with one square minus another square. And if that's the case, I can factor that into two binomial factors, both of which have the square root of the first term as the first term and the square root of the second term as the second term. Plus in the middle of one, minus in the middle of another. For example, x squared is a perfect square, so is 36. If I see a minus in the middle, I know that I'll be able to factor this into x plus 6 times x minus 6 because x is the square root of x squared and 6 is the square root of 36. Plus in the middle of one, minus in the middle of the other. Quick FOIL will help prove this. If I were to check this by FOIL, I'd have x times x is x squared. Negative 6x plus 6x would cancel itself out and be 0x and not be here, which is why you don't see a middle term. And then positive 6 times negative 6 is indeed negative 36. Putting that to work, if I have x squared minus 9, for instance, x squared is a square, so is 9, and there's a minus in the middle. I'm going to go ahead and factor this expression into x plus 3 times x minus 3. Quick FOIL, x squared minus 3x plus 3x is gone, and negative 9 at the end of it. There you go. And one more, x squared minus 144. Same pattern at work here. Both of these are perfect squares. Square root of x squared is x. Square root of negative 144 is going to be positive 12 and negative 12. So x plus 12, x minus 12 would be my two factors. Now, the other factoring pattern that we should be familiar with is the perfect square trinomial pattern, because we dealt with this when we completed the square to solve quadratic equations. So if I have a square at the beginning, a square at the end, and twice their roots in the middle, I can factor this into the square of a binomial. The binomial starting with the square root of the first term and then ending with the square root of the second term. For example, x squared plus 6x plus 9 can be factored into, well, let's see, x is the square root of x squared, 3 is the square root of 9, so x plus 3 squared would be my factors. Now, again, quick foiling in our heads, we could check this out. Square the first term is x, multiply the two together is 3x, double it is 6x, perfect. Square the second term is 9. There's a minus in the middle. That means there's a minus in the middle of my binomial. X squared minus 14x is 49. Well, that must be x minus 7 squared. And there it is. Putting that to work with one example, x squared plus 16x plus 64. Well, let's see. Those are both perfect squares at the beginning and the ending. And I bet that middle number is a combination of the roots. And indeed it is. X plus 8 squared. A little quick FOIL to check. Square the first term is x squared. Multiply the two together is 8x. Double it is 16x. Square the second term is 64. You could always think about this using our regular factoring tricks with, putting x as the first term in both binomial factors and then thinking about factors of 64 that add up to 16. Well, that'd be 8 and 8. But because it's a special factoring pattern, it's a little bit easier, a little bit quicker to just simply write out x plus 8 squared rather than having to think about it as two binomial factors. So that is factoring using some special factoring patterns.